Gone are the days when tower climbers are the only people at risk for RF hazards. Now, workers like painters, waterproofers, HVAC technicians, and in some cases, general contractors are exposed to the dangers of RF. With the help of our friends at FieldSense, we put together a quick overview of RF, its potential dangers, and how they can be easily navigated with a bit of knowledge. To start, let's talk about what RF actually is. RF, or radio frequency, is a segment of the electromagnetic spectrum and is commonly used for telecommunications like TV, radio, and cell phones. It is represented by this green segment. Some people may be aware of the dangers associated with overexposure to the high end of the spectrum, but fewer realize that there are dangers of overexposure of RF frequencies too. While not as severe as ionizing radiation like gamma rays or X-rays, overexposure to radio frequencies can cause heating of the body that can lead to or compound other issues like overheating, dehydration, and ultimately heat stroke. And with the deployment of small cell wireless transmitters on rooftops and all over our society to improve network speeds, techs can be exposed without even realizing it. So, what levels of exposure are potentially dangerous? The amount of radiation absorbed is affected by the length of time exposed, the strength of the signal, and the frequency of the radiation. Safe limits of exposure are impacted by these three factors. The strength of RF drops substantially when working at a distance from the antenna, which is one of the major reasons why the general public, for the most part, is unaffected by RF in their daily lives. But with the addition of smaller antennas and more densely populated areas, the risk of exposure is higher than ever for techs. This new reality is why it's so important for employees working around antennas to have training in PPE to mitigate their risks. Here are the normal at-risk zones. The yellow zones represent the general public exposure limits, and the red zones represent the exposure limits of the RF worker. Both the type of antenna and the power into the antenna determine the risk zone size. It is also common with co-located towers, or towers that have multiple antennas and carriers, to have zones that begin to overlap, creating compounding zones, which increases the power density in the overlapping area. Complications such as these compounding zones makes it critically important to have an RF monitoring device. The two main types of antennas that impact the footprint of the RF hazardous zones are called omnidirectional and directional. As shown here, the omnidirectional antenna has a distinctive circular radiating pattern, whereas the directional antenna strongly weighs in one direction. So how can you be sure that as a technician potentially exposed to RF transmissions, that you're being safe while on the job? First, employees maintain responsibility to ensure that workers are not exposed to levels of RF exceeding the legal standards. Signs should be present on any site that is known to have RF present. Red zones are known to surpass occupational limits for RF trained workers, and both red and yellow zones are known to surpass public limits for general workers and the public. There is no way of visually knowing what the power levels are at any antenna site, so a personal RF monitor is required to know what the accumulated level of exposure actually is. The only reliable way to know the exposure conditions around transmitting antennas is to measure the levels using a personal RF monitor, which measures both E and H fields. For more information about E and H fields, you can take one of our RF online courses. RF monitors alert workers when they are at risk of elevated exposure limits, so they can move from exposure risks. When choosing an RF monitor, these 5 things are a must. First, the device must have a shaped response to account for the human body's susceptibility for RF absorption. Next, the device must have both electric and magnetic field probes for accurate far field and near field assessment. The device must have isotropic probe architecture for sources of radiation from multiple directions and polarizations. The device should be able to be used both on body or handheld. And finally, the device should provide data displayed with a simple, broad range exposure indicator that shows cumulative exposure as a percentage of cumulative exposure allowable limits. We hope that all this has given you a better understanding of RF and how it can have an impact on your day-to-day life. If you'd like to take a deeper look into RF exposure and training, check out the Safety LMS online RF awareness training course, which goes into a lot more detail and provides you with education you need to work safely in RF environments. Through roughly 1 hour of training, we go into detail on how to measure wavelengths, regulations, near field versus far fields and their heating effects, different types of antennas and their risks, RF monitors and other PPE, and warning signs of RF exposure, including best practices for treatment. Thanks for watching. We hope this brought you some value. For some information, check out gmesupply.com/FieldSense for RF monitors that'll help keep you safe on the job.